Hey fans, Noobie Coders here. Yes, so I went ahead and added some code and modified the graphics somewhat to get us primed for today's lesson on barriers and collision detection. But first, a quick review. Ethereal barriers are those that don't really exist and for all intents and purposes are considered invisible. These actually are numerical constraints on our ball object via code. Physical barriers are those that do exist in the physical sense and are in fact visible. These don't directly constrain our ball in its movements. Therefore, these will need additional collision routines for detecting and reacting to. If you really notice here, the ethereal barriers that I contrived are merely variables. They simply compare your red ball's x and y coordinates to our ethereal barrier as the point of no return. If you look here at the dimension variables, you'll see them listed as left ball, right ball, top wall, and bottom wall. Okay? These are analogous to programming one of those invisible fences. Such as a dog with a barking problem. As your undisciplined canine approaches one of these four pre-described barriers, it gives it a rather persuasive shock to warn it to keep its distance. So too shall we have our red ball. So too shall we tell our red ball that it cannot trespass beyond this region of space. So if the ball is on a horizontal plane and it's going right to left, we say, it's getting to 20. As it gets to 20, boom, that's it. It's going to smack in there. We won't let it go any further. If it's going left or right and it comes up on the right wall, well, the right wall says 370, that's the max. Bam, it's going to hit that. And then, of course, the top wall is 20 and the bottom is 600. Okay, so why don't we just see this running, okay? You'll notice I did quite a lot of changes on the screen. I want to show you this, though. See these blue arrows facing each other? Well, these approximate where our visible wall is located, which is right about in here, okay? So let's puppy running, all right? We're moving along. Bam! Okay, we hit something. But it's not there, right? That's because we programmatically told the red ball it cannot go past a certain x coordinate on a horizontal plane on our form. I know this doesn't look very sexy, but it serves a noble purpose. Many times you will have minor players moving about in your game. These could be a flock of birds, flying overhead, front to back, or the sun tracking east to west, or maybe a car crossing an intersection. It might be right here. We want these objects to come and go under complete control and without wandering off screen, unaccounted for. Okay, remember back in part 4, I think it was part 4, I showed the ball moving along. Well, if you don't have something to intercede, it will keep going and it'll go right off your form. Okay, just because you're at the edge of your screen doesn't mean the ball is going to stop for anything. That's why you have to have complete control of what you're doing. Okay, I didn't show you all the variables. They're pretty self-explanatory. We have a start X and start Y. This time I moved the X a little closer to our barriers. I introduced a tracker X and tracker Y. It's easier to, if you're adding a couple numbers together, it's easier just to assign all these numbers together, like a start X plus maybe a counter variable to the tracker X or tracker Y. Makes life easier for the programmer. Okay, we have a collision counter. That's what the call count is. And we have a couple corners, okay? They come in two flavors. We have a bottom right corner and a top right corner. And of course, whenever you're assigning coordinates, you need X and Y for each one of those. And I basically already went ahead and said, I know where that's going to be. I know where that's going to be. You'll see. And then finally, the last variable I set up was a random split variable. Okay, I'll show you that in a little bit. Let's see how this routine actually works, okay? The ethereal barrier routine right here. Okay, that's the red ball banging into the contrived variable wall. Basically, it's real simple, guys. Here we have the x coordinate of the R ball. It's moving on horizon, the horizontal plane, and basically I say if it's greater than equal to right wall, which is just a variable, right? Then I just say, hey, reposition it in the center, the mid x, mid y. That was the penalty box I show you. And of course, if it's not quite there yet, we just keep incrementing. Now, remember how I said tracker X earlier? It's so much easier to use the word tracker X than to constantly keep adding start X plus count, start X plus count, start X plus count. See what I'm saying? You assign it once, and then you can reuse that variable. That's why I use a lot of variables. You know? Just thought I'd say that. Now, physical barriers. Let's start the code again. This is our physical barrier in our game. Physical barriers are way cooler to work with. This is because you get to visually see the action in real time as it occurs. I mean, who doesn't want to see a car wreck in action, right? When our ball smashes into our green barrier, we need to code for this event. So by now you're probably scratching your head trying to figure out one big question. How can you have two disparate objects, a picture box and a label, smacking into one another? I mean, how are you showing these objects colliding? In a word, bounds. Okay, let's look at this line here. It seems that the programmers at Microsoft were pretty smart about this. They put a bounds element inside of all our objects that we would think of animating. So basically you're taking the red ball, its bounds, and then you say, hey, if it's intersecting with, right, that's one command, and then in parentheses, a green barrier, its bounds, okay? This looks really long to type out. In fact, let me just do that real quickly with the IntelliSense running. It looks cool when you see this. See? It doesn't look like it's right there, but it is. Intersects with, all right, so that's already right there. And then, of course, then you pick your other object, and it should be in there. And then there's going to be a bounds in there. Notice that it's not really showing up in IntelliSense. Don't worry, it's going to. All right, that's it. Now, of course, it's an if-then. It's going to want the if-then. I just want to show you, though, don't get messed up because the IntelliSense doesn't, quite look like it's working. It is. It will work. You just have to believe in the code, okay? So that's it. It's really not that hard. So, basically it's overlapping with that. You know what I mean? That's really kind of cool. That saves you a lot of work. I wouldn't even know how to do this hardly at all without that. It can be done, but it's a lot more coding. So praise Jesus for Microsoft engineers, okay? Okay, so here's our call count, right? Our collision counter, right? So basically, you have a couple things you have to do. Okay, so first of all, you detect that an intersection or collision, however you want to word it, occurs. Then you want to right away increment your collision counter, right? Because it is a game, that's what you're trying to do, right? You want to say, hey, you got to hit. Now, and normally it would be like, all right, you hit something, you can deduct points or you can kill your main character. This could be a dead thing. And how many times did you die? That kind of thing. But we just want to look at how many collisions for now. And then, of course, we take the collision counter, we put that in the text box. And remember, we're adding toString again so that it will show up. And then here's your random split. I'll go over that in a second. Okay, this basically is a subroutine that randomly pick which corner of the screen that we want to redraw our ball into, okay? So instead of having the ball relocate to the top right or the bottom right corner, we could actually do a little more than that. we can have it go into many assigned areas. You know, maybe we could have it go here or here or here or here. You know, that would be great, right? So that's what we'll probably end up doing with the maze game that's coming up, in efforts to frustrate the player all the more, right? So that's it. I hope you learned a lot today about barriers and collisions, and that'll do you. Take care. Bye bye.